Let us discuss about consumer function interface. Where it comes from. Consumer is part of the Java standard function interface. That is Java.util.function. It was introduced in Java 8 and it is mainly designed for operations that take input but returns nothing. It takes the input, it returns nothing. So what is consumer? A consumer of type T represents a function. It is a function that takes an input of type T and performs an action, no return value. So it takes the input, it performs an action and it doesn't return anything. So what is core method available inside the consumer function interface? Void. Void accept T. So example, let us see the scenario of our school context. It takes a student object and it just prints it. The name system.out.println s.getName. So here we have of consumer of student, variable name print student, and returns the student object and prints the student name. So after that we need to apply the accept. Print student dot accept student. So if you think like this, do something with this object. So we are telling the consumer that you need to do something with the object and don't return anything. So what is consumer? So a consumer of type T is a functional interface used when you want to consume data and perform side effects. So when you want to consume data, here in this case student object, and perform side effects. Perform side effects like printing the marks of the student, printing the name of the student, etc. So without returning any value. Here we are not returning any value. In this case we are just printing the student name. So let us see why consumer exists in the first place. So we're trying to understand the necessity in our school systems that we're building. So in our modern unit, we often need to log student activity, send notifications, and print reports, student reports, and update audit logs. So these are all actions. So if you see log student activity, we are logging student activity, we are sending this notifications, and we are printing the reports, and we are updating the audit logics. So not transformations. Just like function interface, we are not transforming anything here, but we are just doing all these kind of things. So without consumer, so let's see how it used to be without a consumer. Without a consumer, we are using enhanced for loop. We are taking the students and we are printing the e students inside the for block. Inside the for block, we are printing the e student s dot get name student s, and we are taking the students object. So inside the for block we are printing the e student. So with consumer. So how it happens with consumer? With consumer we just taking the consumer of student, print name, variable name, est. We're taking the object of student on the right hand side. It is the lambda operator followed by printing the name. Assume that we have student Kojo where we have instance variable name, we have the getter. So let's try to apply the for each loop on top of it. Print name for each students dot for each print name. Now action logic is reusable. We have action logic is reusable. Cleaner pipelines and clear intent. This is a side effect. We are taking this student object, we're just printing the name. So let's see in a scenario of a functional programming perspective. So consumer is side effect executor. It is a side effect executor, meaning it doesn't transform like take the student object and transforming the name of the student into the lowercase or uppercase like that. It doesn't return. It doesn't return like after transforming it return, in functional interface. In functional interface, what we do? We transform the input and returns it. But we don't do these two things as far as this consumer functional interface is concerned. It doesn't transform, it doesn't return, it executes behavior. It just executes behavior. So let us see the example of passing consumer. As an input parameter. Here we have a method named process students, which is a static method and that returns nothing. So here it takes this method takes students of type list of students and it performs an action and it also takes another input parameter action of type consumer of student. Here students, on top of the students we are applying for each of action. Here we are inside this method actually we are passing the behavior. You can see, if you can carefully see, process students, we are passing students and also we are passing here behavior. It takes a student object and it prints the name. System.out.println student object dot get name. So let us see the composition. Consumer composition is very important. We have built-in method like and then execute multiple. It is useful for executing multiple actions. So example, here we have consumer of student with variable name print name. So on the right hand side we have student object followed by lambda operator and we are printing name system.out.println s.get name, and then we have again consumer of student with variable name log marks. On the right hand side we have student object followed by s.get marks. So now let's see the combine operator using composition. So consumer of student here again with variable name combined. Now on top of this print name we are applying and then with log marks. Then combine dot accept. We are applying accept method available inside the consumer function interface. Why it is a functional interface? Because we have only one single abstract method available inside the consumer function interface. So we should think of consumer as action composition action is action chain. It is a chain of actions. First, we are printing the name, and then we are also printing the marks. So it is a chain of actions. So let us see the real world usage patterns in the context of school modules. So in the logging module, we have consumer of student with the variable name log student, and on the right hand side the student object, and we're printing system.out.println student accessed with s.get name. So notification trigger. Inside the communication module, we have consumer of student with variable name send notifications, and on the right hand side student object email service dot send s dot get email id. We're seeing all these in the demo, and in the admin module for printing reports we are using this consumer function interface student dot for each s dot system dot out dot println s. We are printing the student object. What we are doing here, we are inside student pojo, we should be overriding this toString method. So side effect after processing. So side effect after processing. Consumer as a side effect after processing. We have students object. We are applying stream on it. After that, we are applying filter method, which will take a predicate. So student object s followed by lambda alpha s dot get marks greater than 40. We are actually what we are doing here. We are filtering the students who have got more than 40 marks, and then applying a for each method. For each method actually is taking a consumer function interface. So again student object, and we are printing. First we are filtering the students who have got above 40 marks, and then we are printing their names with the help of consumer function interface. Actually with the help of for each method, which will take consumer function interface. Internally it applies accept method. So primitive personalization. So consumer primitive personalization. So instead of consumer of integer, you can simply use int consumer for marks, log consumer for IDs, and double consumer for fees. So example, int consumer print marks is equal to m dot system dot out dot println m. So internal working. When we write actually consumer, let us see the internal working. When you write actually consumer of type consumer of student with variable name c s lambda operator student dot out dot println s dot get name, it converts lambda into function interface. And then uses invoked dynamic. Use invoked dynamic and then optimized execution. Also optimized execution. These three things happening internally when we write like this. So conceptual equivalent. Actually, when you write like this, it uses the anonymous inner clauses like this. Consumer of student C is equal to new consumer of student override. It overrides the access method inside the consumer function interface. So internally it converts like anonymous inner clauses. So let's see some common pitfalls using consumer for transformation is one of the common pitfalls. So we shouldn't use consumer for transformation. Why? Because this mutates the state, dangerous in pipeline. So actually it mutates the state, it changes the state. So only we should use binary operator instead. In this case, we should be using binary operator. Why? This transformation is happening here. We are taking the student object and we are applying 5 marks for student marks. So here it takes the student object and returns the student object itself. So we need to be using binary operator here. So hidden side effects. Students dot for each. Yes, followed by lambda operator database dot save as. So here it is hard to debug implicit behavior. So avoid using consumer in sprints. Avoid mixing business logic to side effects. So this is also one of the common pitfalls. Hands-on demo we'll be seeing a while from now. So what are the final takeaways? Consumer here takes the input and returns nothing, and it is used for side effects, and its core method is accept, and it supports action chaining with the help of and then. It is ideal for if you see in our school module models application logging, notifications and printing and auditing. That's it as far as the theory goes. Let us see the demo. Let us create a package with name consumer functional interface. Now what we're going to do first, we're going to create a closure. The student will have marks. Let us suppose for now we're making it simple. The student will have name, student name. So we are creating constructors and getter constructors for this, as well as we are also generating single parameters constructor. Fine. Now let's create another class, which is the driver class, consumer functional interface demo. Make it very simple, consumer demo. Fine. We'll take main method. Inside the main method, what we're going to do? First, consumer of type student. So print student is equal to, we take the student object here, followed by lambda operator. We are printing the student name here. System.out.println dot get name. Fine. Now what we are going to do, on the print student dot applying access method. So new student, the student name is, let us say let us try to debug this. F8. So it is printing from here. Fine. Now let us see the scenario of consumer without without consumer and with consumer. Without consumer demo. Main method, and we have a list of students, list of student, and students is equal to, we are applying off method, off static method available inside the list interface. So what we're doing here, we are taking some fluid objects. New student, first one is Ramu, new student, second one is Ajay, and the new student, third one is Praveen. These are the list of students we have. So now, your consumer, what's happening? We'll take enhanced for loop for student student student. So we are printing each student name, get name. So this is the thing without consumer. Ramu, Ajay, Pranay printed, right? So we'll do without and with consumer demo. So we'll write without consumer. With consumer. So with consumer, what we're going to do? We're going to, on top of the student, we're going to apply this first consumer or student print name is equal to, we are taking student object and what we are doing, we are printing it. Student dot get name. So on top of the students, we are applying for each method. For each will take consumer function interface. So print name. So we have seen without consumer, we will see now with consumer. With consumer, we printed Ramu, Ajay, Pranay. So we simply passing the print, we simply passing the consumer inside the for each, because for each takes consumer function interface. Done. Now let us see the composition, the chain of actions we have discussed. So what we are going to do first, we are going to take the consumer of student and the reference variable print name. We'll first print the student name and then we'll print the marks. We'll take another consumer of student with reference variable log marks now and then we'll print the marks and then we'll combine it. Finally, we're applying on top of the combined object, we're applying except method. Let us see that in action. What I am going to do, I am going to take another package inside this. I'll make it as 1. So I'll copy this and I'll paste this inside this. My intention is to take private on the reference variable private into marks. So I will first generate a constructor for both of these fields, and then I will create gets and getter setters for both of these fields. Consumer demo. So main method I have inside this. First I will take consumer of type student, print name equal to student dot get name, and then we will take another consumer of student log marks is equal to again student object student dot get marks. So now let us apply the composition. Now consumer of student combined is equal to print name on top of it, and then log marks. Fine. Finally, we are applying the on top of this combined. We are applying combined object. We are applying acceptor. New student. The student name is again Pranay, and let's assume that he has got some typo here. Let us assume that he has got a marks 80. So we try to print it. We should be actually having two string method.